Today's video is about rotations and dilations. There are rotations about the origin. You can rotate a figure more than 180 degrees. In our class, we will rotate figures 90 degrees, 180 degrees, and 270 degrees counterclockwise. A rotation of 360 degrees returns a figure to its original coordinates. So, for example, I have a little heart here that I will place in the quadrant 1. So when I rotate it 90 degrees, then it ends up like this. And then, so that's 90. Okay, and then if I do 180 degrees, or 270 degrees. So, is a rotation an isometry? Yes, it is. An isometry, remember, it preserves its size and shape. We have rules that we can use to find coordinates of a point after rotations. And so this is what we have here. So for 90 degrees, we have xy. We can just change the coordinates to negative yx. And that one, if I have my xy coordinates here and I plot this at 4, 2, and I travel 90 degrees, I end up here. My goodness. I end up at negative 2, 4. For this one, it ends up just becoming the opposite of what I had. So the opposite, these are both opposites. So if this is at 4, 2, and I go 180 degrees, I end up at negative 4, negative 2. For a 270 rotation, the rule is y negative x. So again, I'm at 4, 2. And if I go all the way around to here, I end up at 2, negative 4. So that's all right. So my rule is, my example, rotate quadrilateral ABCD 90 degrees about the origin. So the rule is xy, then turns into negative yx. So if I have A at negative 3, 1, I'm going to make this a -1, -3. This one's going to be a -3, -3. So this is my y. I'm going to turn it into a negative and put it first. And then this stays the same as the x was, and this becomes the negative of the y, and the x goes there. All right, so let's plot these points. I have -1, -3. So this is A prime. -3, -3. This is B prime. I put the A prime in the wrong place. It should have been at -1, -3. Okay, I thought that would look weird. Anyway, 1, 2, 3, -3, 1, that's C prime. And -1, 1. D prime. All right. Okay, so now let's rotate about the origin 270 degrees, and my rule is y -x. So 0, 2. 2 is going to go here, and this is going to be negative, but 0 doesn't become negative. The y is going to stay the same, the x is negative. The y stays the same, the x is negative, the y stays the same, and the x is negative. All right, so then we just plot those points. 2, 0, 4, -1, 4, -6, and 2, -5. All right, and so that's A prime, B prime, C prime, and D prime. So knowing these rules is going to be very helpful. All right, so rotating 180 degrees, -x, -y, in the same order. All right, so -2 becomes +2, 0 stays the same. -3 becomes +3, -2. -2 becomes +2 with a -4, and we have a +1 and a -2. So 2, 0, 3, -2, 2, -4, and 1, -2. And we have rotated the point 180 degrees. Okay, so since we're talking about rotation, let's talk about rotational symmetry, which is when a figure is rotated around its center less than 360 degrees and maps itself. So for example, this one is this is the center, and if we rotate it, this will be right on top of itself. 1, 2, and then 3 times. This one doesn't ever map itself, or it does once, okay? And then this one, we have 1, 2, 3, 4, 5 rotations. I'm going to end the video and go ahead and watch part 2 for dilations.